Hi, everyone. I'm so excited and happy and honored to be here in Monitorama. Observability is one of my favorite topics to think about, to discuss with people, to teach about, and so I'm very excited to be here at Monitorama, the whole event dedicated to discussing this very important topic. Today, I would like to talk about software supply chain observability with Grafeas and Kritis, the two open source projects that I'm leading. So a quick thing about me, I'm a senior software engineer at Google. I have worked on a variety of infrastructure projects, such as search infrastructure, developer tools infrastructure, drive infrastructure, and now I'm on the Google Cloud infrastructure team. I'm the eng lead of two open source projects, Grafeas and Kritis. I get paid full time to work on open source. That's pretty sweet. I'm very excited. I can be found on Twitter. Aysylu 22. If you're wondering about the number 22, that's not my age. So today we'll talk about software supply chain management and what it is, the two projects, Kritis and Grafeas, and then the upcoming release for Kritis and Grafeas we're very excited about to get more of your feedback. So a quick show of hands, how many of you are familiar with the term software supply chain? Okay, perfect. I'm seeing maybe a third of the audience. So for those of you who are not, I'm going to go through this, and hopefully we'll get all on the same page to discuss further how Kritis and Grafeas provide building blocks to provide observability around that. So just like with food supply chains, where we first plant the seeds and then grow them and harvest them and then bring the food into onto the table, and we want to track the whole process. Similarly, with software supply chain, it will allows us to track the code from the time it's written to the code check-in time it makes to the source code to the time we build the images or we build the binaries. We test them and verify them, and usually these days we can automate this with continuous integration pipelines. And then we do some QA, maybe automated, manual, and then we deploy it to production, which can be automated using the continuous delivery pipelines. So now, just like with food supply chains, we might wonder, where did the food come from? Is it organic, gluten-free, vegan, and so on and so on? Which country it comes from? With software supply chain, we'll wonder who wrote the code, what third-party dependencies we have, are there vulnerabilities in there that we should know about and mitigate, and who deployed it to production, and so on and so on. So now, so the main question that we ask here is, what happens to the code from the time it was written and got to the source code, the code base, to the time of the deployment, being able to track the whole journey through this to deployment, and then gets undeployed throughout the whole software supply chain. So for this, we have a bunch of options for CI/CD pipelines. Many different vendors provide excellent tools, and we built some observability tools around them. But this is the area that is not super well developed in, and so I would like to talk to you about how Grafeas and Kritis can develop this. And the reason why it's not very well developed is because this is newer-ish, especially when it comes to containerized world. And so being able to track this and build this around all the different vendors you might be using is a problem that we would like to solve with Grafeas and Kritis. So let's look at how Grafeas and Kritis fits into the software supply chain. So we have an engineer who writes code, and then she would like to build and deploy her code. So she will use any of the number of CI/CD pipelines available to securely build her code, run automated testing, scanning for vulnerabilities, maybe license scanning, and doing some analysis on her source code, and then doing deploy checks before it makes it to production. And so all the different options for CI/CD pipelines, all of them can output from every stage of this into Grafeas centralized knowledge base. And so here you would store information such as who built the code, what vulnerabilities it has, and so on and so on. And so it provides the centralized metadata knowledge base. So now for deploy checks, we can use Kritis, which is an admission controller in Kubernetes. where we can run and enforce policies for us. For instance, the severity of vulnerabilities. Like if we're only okay with, say, medium severity, anything with high severity, we want to make sure that that doesn't get deployed. And where the image came from, does it come from trusted location, and so on. And so if our container and binary passes these checks, then our code will make it to production, and otherwise we'll just deny this and then write why we rejected it, what policies didn't pass. Okay? So now all of this, how Kritis and Grafeas work together are, well, Kritis doesn't store information about vulnerabilities, about image location, and none of that. It just runs the policy checks. And it will talk to Grafeas to actually get the metadata about the artifacts you're interested in. So that's kind of like how they fit in here. And so now the observability part is both, I apologize, so Kritis and Grafeas can provide different parts of the software supply chain information, recording information about what happened and being able to get this full view of the software supply chain. Okay? So Grafeas and Kritis are not new projects, and they also have proprietary implementations on Google Cloud. So the projects have been around for some time, and so just saying that it's not just like a type project that appears recently. So they've been proven, and if you're wondering what they mean, Kubernetes ecosystem has this habit of using a lot of Greek names, so it might help to know what these projects mean exactly. So Grafeas translates as scribe, so like centralized metadata knowledge, right? Like writing down metadata information about your artifact. And then Kritis is translated as judge, so judging at deploy time what gets deployed and enforcing policies. Okay, so we talked about software supply chain. Now let's talk about how Kritis and Grafeas fits into this. How many of you work in the containerized world where you run a lot of different containers? Okay, most of the room, great. So specifically, Kritis is, how many of you work in the Kubernetes environment or use Kubernetes? Okay, again, most of the room, so perfect. So let's talk about Kritis. Okay, one more question. How many of you already know about Kritis and Grafeas? Kritis, show of hands, okay, some Grafeas? Okay, perfect, couple hands. Well, I'm very excited to share this with you now. So Kritis was developed as open source first project. It's available on GitHub, and in the whole software supply chain, it specifically refers to the deploy time, the very last stage. So it's a deploy time policy enforced is the way you can think about it. So let's look at the example of how it works to understand where it fits and why it's useful. So let's pick an example of e-commerce website we would like to deploy to production. So we'll do kubectl apply commands. If you're not using Kubernetes, you're not in that environment, don't worry about it. The example will still make sense, so don't worry about the specifics of commands. So now we'll deploy our pod with a container in its site in a YAML file. So, okay, we have our command, and it will be sent to the Kubernetes cluster. Okay, so Kritis runs inside the Kubernetes cluster, and the way we achieve this is by doing helm install, which is package manager for Kubernetes. And so we'll install Kritis will just now run inside in a very well-integrated way. So now our kubectl command will send an admission request with a pod specification, which will be accepted by the webhook. And now this request will be reviewed, and we'll have a bunch of policies. Imagine that we have image security policies. So what I mean by that is policy for what vulnerabilities we're willing to tolerate, how severe of those vulnerabilities we're willing to tolerate, and so on. So for each of the namespaces, say QA and prod, will have its own policy. So now it will be enforced by the validator, which is some logic that actually does the checks for the policies. And so now we'll fetch metadata from Grafeas, and the API is backed by some storage. Doesn't matter what. It could be any storage. We have implementations in open source for Postgres and the in-memory store. Internally, we use Spanner, but really the API is so flexible that any storage backend you're able to integrate it with any storage backend. Okay, so now we sent our request, and there's no vulnerability information. So vulnerability scan hasn't finished. So what happens now? Well, the request will get denied because we have a image security policy in place. So that means we want to ensure that the scan has run and that we have some information about it. So it'll get denied. Now, vulnerability scanning has finished, and we have a vulnerability that we found. So now at this point, say it's a high severity vulnerability, so then again, we'll deny the pod. Now, vulnerability analysis is a very hard problem. There's many different vendors in this space that are trying to solve this. And so we manually inspect this container and realize that this vulnerability doesn't actually affect us. So we can whitelist it, which is something that the policy allows. And so now we'll be able to accept the pod. OK, great. So now we're doing well. We checked it. We are able to deploy it. So now let's scale up our system. So we're able to serve more users. So we'll do the kube control scale to 4 replicas. And then the second replica came up. And then while third and fourth replica are coming up, our vulnerability scan found a new vulnerability. So vulnerability scanning will most likely be running as a separate process in your system. Maybe you're talking to a vendor that is doing it for you. And so does this mean that now we can't deploy because anytime a new vulnerability is found, we just are not able to deploy? Well, to prevent this problem, to ensure that we're still able to run our website, our service without interruption, what we'll do is we have attestations in Kritis. So taking a step back when we first deployed the first container, the first pod, so we have an attester within Kritis that basically writes attestations into Grafeas for any admitted images. So now anything that passed the checks, anytime you scale up, or continue deploying it, it will be able to be deployed without interruption. And similarly, this helps with when pods get restarted, because when pods get restarted, it looks the same as a new admission request to Kubernetes, and so we want to be able to run our application in an uninterrupted way. And so now we're able to scale, and even if we find a new vulnerability, we'll just fetch the attestation for this image, and then we'll deploy it to production. OK, great. So now what does this mean for new vulnerabilities? Say Heartbleed comes along, it gets discovered, and we want to bring down our pods and address that and make sure that we are safe. So for that, we have a background cron, which is looking at all the running pods, currently running pods, and then it will run the same policy checks and then run annotations and labels for any pods that no longer pass the security policy. And for those that still pass. And so this way, cluster admin can take a look at it, analyze it, and then take the appropriate actions. Great. So if you're wondering what image security policy looks like, it's a CRD for those of you who are in the Kubernetes space. So it's a custom resource definition. And it basically looks like, in a YAML file key value. So we'll define the image security policy and then give it a name. And then the spec, we can whitelist images that we want to always deploy because we verified something about them and we know it's OK. Define maximum severity, and then whitelist some vulnerabilities that we know don't actually affect us. So it's pretty expressive, and the goal was to add more of different kinds of policies to make this very flexible. So how do we do observability with Kritis? Well, it doesn't, besides the policy checks, it doesn't it enforces the policies, but it doesn't actually, write to a specific monitoring source. So it's a building block for this. So it allows us to answer questions such as, when did the image deploy? When did it pass policy checks? When did the image stop satisfying policies if new vulnerabilities get discovered? And so, and because it's an open source project, if you want more of different types of events monitored, then you can just add the hooks into the source code, and it allows you to track the whole process from the time that admission request comes in to the time it gets to the deployment to production or any environment. Okay, so to sum up, Kritis is an open source project built with community and industry contributions. It plugs into Kubernetes admission controller. It attests images and verifies the past policy before deployment. And it allows us to apply consistent policy across Kubernetes environments. So we talked about Kritis. Now let's talk about how Grafeas fits into all of this as well. So Grafeas, the stages that it covers in the software supply chain is all of the stages. So you're able to write metadata about the source and the build information and the testing and deployment and so on. And it's also available on GitHub, developed as open source first. So I'll be referring to Grafeas, and you'll see it all over the mailing list as artifact metadata API. So let's unpack that a bit to make sure we're on the same page. So artifacts are images, binaries, packages, doesn't really matter what. So now we're like stepping away from containerized only world into any environment that you have, any development environment. Metadata is build, deployment, vulnerability information, licensing information, any type of metadata you would want to track about your artifacts. And the API allows you to store and retrieve metadata about artifacts. So a couple of interesting points of terminology to make sure we're all on the same page. Notes, there's a concept of notes in Grafeas, which are high-level description of types of metadata. For instance, in the industry, we use the term CVEs for common vulnerabilities and exposures, and they will be stored as vulnerability nodes. Now, also the concept of occurrences are instances of nodes in an artifact. So for instance, the presence of a specific vulnerability in an image will be stored as a vulnerability occurrence. Now, we use the concept of resource URLs, which actually allows us to combine and have the unified view across the whole software supply chain. So those are identifiers for artifacts and occurrences. For instance, you have Debian packages or Docker images or generic files. And all the different occurrences that you write, all of them can be connected by that resource URL across your software supply chain. Now we use kind-specific schemas, which are strongly structured schemas. And the reason for this is, first of all, we want to make sure that it's easy to add any kind of new metadata kind that you wanted to track. And also it allows us to ensure that we have a unified view across all the different vendors of the same type of metadata. So if you're using CI pipeline and like you're writing the testing information, then making sure that all the different vendors that you might be using are speaking the same internal language, using the same metadata type. So an example is a deployment node. Say you have an artifact that you want to deploy, and so it will have the field resource URI. And then the deployment occurrence in a different environment would have information about who deployed it, user email, deploy time, at what time it got deployed, at what time it got undeployed. I don't have all the fields here just for the sake of space. And then it will all be connected by the resource URI. So now how do we use Grafeas as the building block for observability? Well, because it allows you to store metadata about every stage in the software supply chain and then connect that for a given artifact across all the different stages, then you can use this to be able to monitor what happened from the time the code gets submitted to the time it gets deployed and undeployed and everything in between, and figure out what's going on in the system, why the fix hasn't been pushed, or when is it being pushed, and so on. So to sum up, Grafeas is a project that was developed open source first. It's an open artifact metadata standard with contributions from the industry. Use it to audit and govern your software supply chain. It's a knowledge base for on-premises and cloud clusters. So we keep in mind that most of us are using hybrid cloud solutions. So it's meant to provide a solution for hybrid cloud use cases as well. And it's an API with pluggable storage backends. I didn't go into very many details, but I mentioned that you can use it with any storage backend that you need. There is already integration with Postgres and Spanner, and there's a in-memory storage as well. Okay, so we talked about Grafeas. Now let's talk about the upcoming release of Grafeas and Kritis, and this is where you're also able to come in with your contributions and feedback. So I'm very excited that 0.1.0 release is coming out in this quarter, in Q2. And there are 3 goals for this release. First of all, it's to enable users to start experimenting with Kritis and Grafeas. The one feedback that we got from a lot of people in the community is, this sounds great, it's awesome, but I can't do much with it. So this release will allow you to actually bring up Kritis with Grafeas and then play around with it on a Kubernetes cluster. We're moving towards hybrid cloud support. So if you're using any of the cloud providers and you have an on-prem requirements, then you'll be able to use Grafeas and Kritis all across the environment. And the goal is also to gather community feedback by providing this useful thing that you can experiment with, helping us prioritize all the different features. We have many different ideas for what we want to do with this, but all of us have different goals, and we would love the community feedback for what we should prioritize and accept contributions for all the different use cases. So the scope is to provide standalone Kritis on Kubernetes with standalone Grafeas. So you can just bring it up on your laptop and then play around with it. Now, there's 2 user journeys that we kind of like to enable. So what can you do with it? We'd like to see that you are able to deploy a container to Kubernetes cluster that passes the checks, the policy checks that you have put in place, and then also see how it blocks the deployment of an unadmitted image to the cluster, an unadmitted container. So now the features that we're adding specifically are to Grafeas. We have a Helm chart because we are using it for Kritis in the Kubernetes world, and we'll have a published image if you just want to play around with it on your own. We'll provide standalone Grafeas with server with Postgres backend, and we'll provide a basic support for Go client library. For those of you who are not writing Go, can I see a raise of hands? Okay, we have not forgotten about other languages. The main feedback we got from the community is that many of them are using Go, so we're prioritizing providing support for that, and then after that, we'll be able to focus on other client libraries in other languages. And now for Kritis, we're adding generic attestation policies. So this way, if you're a cluster admin, you can just say, OK, trust this image, be able to deploy it because I've manually inspected it. I know that it's fine. Instead of having to write complicated image security policies or more sophisticated policies. We're defining a default admittance fallback policy. So if you don't specify any of the policies, making sure that that's well-behaved and making Kritis configurable. So I'm very excited about the 0.1.0 release. If you are interested in contributing and using it, please follow along. We have the GitHub repositories under the Grafeas organization, Grafeas and Kritis. We'll have Google groups for Grafeas and Kritis users. And also, if you are interested in actually contributing code, there's the Grafeas dev mailing list that you should join. We host community meetings every so often as the need arises. So we'd love to have you in those meetings contributing your ideas to this and filing issues. And we're also on Twitter at Grafeas.io. And since we're all on Slack these days, there's also the talk, Aysylu Greenberg. If you have any questions after the talk, please feel free to ask me. So I'll conclude this talk with a question. After this, how many of you are interested in using Grafeas and Kritis? Awesome. I'm so happy to see a raise of hands. And how many of you are interested in contributing and see how you could extend and use it for observability for your use cases? Great. Awesome. Looking forward to your contributions. And thanks very much.
We have a few minutes.
We have 2 minutes for questions, so I'll be happy to take your questions. And the lights are bright, so I can't quite see the hands. So feel free to just shout out your question. Yes?
The choice of
So it could be any storage. We got a contribution with PostgreSQL. We have it in memory. Internally, we use Spanner. So it could be anything, really. An active member contributed PostgreSQL, so that's why we have it. But otherwise, it could be really anything. Like we had requests for MongoDB as well. So it's just a matter of people contributing. And I did not talk much about the architecture of Grafeas here, but the goal is that those integrations with storage backends are separate from the project. So we keep the Grafeas project itself as the API of it. And then all the contributions of all the different storage backends are very welcome. Yes?
You talked about the idea of being able to put data into Grafeas. What does the query API look like? Like, what kinds of questions can I ask?
Very good question. So the kinds of questions that you can ask is query the node. Oh, sorry, yes, thank you. So the question is, what kinds of questions, what kinds of queries can you ask from Grafeas once you put the metadata into it? So you can ask, you can list the nodes, so like all the different, say, vulnerability types that you know about. You can list the occurrences for a given resource URI. You can list node occurrences, so for like a given vulnerability, what are all the images that detected this? And then there's a lot more that you can do with it. We, in one of the versions of APIs that we're moving away from, we had the summary of vulnerability occurrences. Eventually, we made the conclusion that this is something that, depending on the vendors, people would like to implement differently. If you'd like to contribute this specific logic, you're very welcome to do so. But as part of, as part of tracking the API and being good stewards of the API, it's not part of the API going forward, but that's a very useful thing that we use internally as well. Thank you. Yes, question?
Should we expect to see this as a bolt-on to GKE soon?
So the question is, do we expect to see this on GKE soon? So as part of the move towards the hybrid cloud support, it will be available in any of the Kubernetes environments that you're interested in. Last question. Yes, go ahead.
Yeah, so Grafeas was originally introduced in collaboration with Google and JFrog. Are you still working together on that?
Great question. So the question is, first Grafeas was announced as a collaboration with JFrog and a couple other partners as well, Black Duck and so on. And so I was still working on that. So right now the focus is, I believe the project started a couple years ago, 2 years ago, and there was a big announcement. And then due to the shifting priorities, we haven't been able to invest into it. So now that I'm working on this full time, we're actually making serious contributions because that's something we would like to see. And the industry has been asking for this, for the open standards for artifact metadata API. And so now the focus of the 0.1.0 release is specifically to be able to allow any user to play around with this. And then going forward, the partners are still there and interested, but we specifically want to give it into the hands so that people can have their own implementations and their own use cases to play around with and their own integrations first. Thank you. All right, well, thank you so much. I'm so happy to see the interest and looking forward to talking with you.